Hello, my name is Eric Swanberg. This is VP number 6, section 5.4, problem number 8. The problem is to apply the eigenvalue method and to find the general solution. So we are given x1 prime is equal to x1 minus 5x2 and x2 prime is equal to x1 minus x2. So we can put this into a matrix. So we're going to let our A equal to this right here. Now we get these values from our given equations right here. So this is our x1 and this is our x2. This 1 comes from right here, the negative 5 comes from this right here. This 1 comes from right here, this negative 1 comes from this negative 1 that's right here. So now we're going to apply the characteristic equation, which is from the book. It's the absolute value of A minus lambda I, which is the identity, that's equal to 0. We know our A, we know the identity, so we're going to solve for our lambda. So if we plug this in, our A minus lambda times our identity, we're going to factor out the negative lambda into the identity. So we're going to have our A plus negative lambda, 0, 0, negative lambda equals 0. Now we're going to add these together. And we get this right here. So now we can take the determinant of this. To take the determinant, you take this value times this value minus this value times this value. And that's what we get right here. If we factor this out, we're going to cancel out a few things, and we're going to be left with lambda squared plus 4 equals 0. So that means that our lambda 1 is equal to 2i, and our lambda 2 is equal to negative 2i. So now we can apply this equation right here. This is basically the exact same thing from above, but now we have a V matrix right here. So we know our A, we know our I, and we know our lambda 1. That's how we're going to plug this all in. So if we do A minus our lambda 1, 2i times the identity times V is equal to 0, we're going to factor out the negative 2i into the identity, add them together. So these are going to be added together first and then multiplied by V. So this is what happens when we add them together, times our V, V1 and V2. So now when we multiply this all out, some matrix multiplication, we're going to end up with two equations. So it's going to be 1 minus 2i times v1 plus negative 5 times v2, and then we're also going to have 1 times v1 plus negative 1 minus 2i times v2. Now, to make it simpler and easier for us to read, we're going to substitute x in for v1 and y in for v2. And we're going to end up with this right here. So now we want to find out some values and see if these are going to be equal to each other. So we're going to solve for our y for the first equation, which we get right here. Then we're going to plug this y into the second equation. And once we plug it in, we're going to end up with this mess. And we're going to keep factoring it out until it gets to the simple form. And it turns out that the left side is going to be 0 and the right side is 0. So this means that these two equations from above that we just found out have infinitely many solutions. So using the equation from above, since from the two equations that we just found, we know that they're both exactly the same. So we're just going to be using one of them. So now we want to solve for our y. Now we can put in any value that we want for x, as long as we do something later about it, which I'll discuss in a second here. So we're going to plug in 5 for x, because there's a 5 for the y right here, and it seems like it's going to easily cancel out. So we put our 5 in for x, and then solve for y, and you see that the 5's will cancel. And our y is going to equal 1 minus 2i. So our V1 matrix of x and y is going to equal 5, which is the x that we just found, which we put in, the number that we made up, 5, and our y is what we just found. So great, now we got that. So now we want to plug it into this equation. Now this would be really hard to solve, so we are just going to use this alternate equation from the book, VE alpha times cosine of beta t plus I sine beta t. This is from the book. So we know from above, from like almost the very beginning, we know that our lambda 1 is equal to 0 plus 2i. So the a is going to be coming from this value right here, the 0, and our b is going to be coming from the 2 right here. So now that we know our v, our a, and our b, we're going to plug it into this equation right here. So what it looks like, we just first plug it in, and we're going to do some matrix multiplication. Not much multiplication, matrix multiplication, but just since this is not a matrix. So it's going to be this times the 5, and then this times the bottom, 1 minus 2i. And we're going to end up with this right here. So now we need to separate the real and imaginary numbers. So we're going to put the reals on the left and the imaginary on the right. And we're going to be using C1 as the real numbers and C2 as the imaginary numbers. So now that we know that, we are going to plug our C1 and C2 in. So we know that these are real, these are imaginary. So we're going to put C1 times 5 cosine 2t, and then our C2 times the 5 sine of 2t. And we're going to add them together for our x1 of t. For x2 of t, we're going to do our C1 times cosine 2t plus 2 sine of 2t, because this is a real number. And we're going to add C2 times sine of 2t minus 2 cosine 2t, because this is imaginary. And we're going to end up with our x1 and x2, which is what we wanted. Thanks.